Hello everyone, welcome to Gradeup. I am Vikas Bhadoria and today is the second class of thermodynamics and application. So as discussed in the orientation class of thermodynamics and application, we have started a course for GATE 2020 for mechanical, and in that today is the second class of thermodynamics and application. Alright. But what we have seen lately in the previous lecture also, that you guys must be busy somewhere in some other exams like RRB and SSC. So we will be delaying this schedule of GATE 2020 for 15 to 20 days, or we will reschedule the complete schedule for GATE 2020. Okay. So in the previous class I have told you about the schedule of this GATE 2020 mechanical course. Today I am telling you that we will be rescheduling this course because your participation in number is quite low in the classes. Okay, so we suppose you are busy in some other exam preparation, so that's why we will be rescheduling the classes for GATE 2020 until unless your exams for other exams like RRB and SSC are over. Okay. Now today is the first class of thermodynamics and application. I will be taking this class, and from Monday onwards there will be a new schedule, new change in the schedule, and then we will come with another plan of GATE 2020. Okay. Because there is no point of taking the classes if your participation in the class is very low. Those who are watching me right now, you can see that all of you have subscribed to our YouTube channel, but still if you are conducting the classes, the number is quite low. Okay, so we are thinking that I think you are busy in some other classes or busy in some other exams, so that's why we will be making a reschedule of the GATE 2020 course. Okay. Now today is the first class of thermodynamics and application, and today I am going to discuss about first law of thermodynamics. First law of thermodynamics. For open system. For open system. Which is also called as a steady flow energy equation. I hope you guys know that. Another name of first law of thermodynamics is steady flow energy equation. Okay. Now in the steady flow energy equation, before going on the steady flow energy equation or first law of thermodynamics for open system, let me firstly tell you what is first law of thermodynamics for closed system. Okay. So in the first lecture I have told you about what is a closed system, what is open system. A closed system is a system in which there is only energy interaction, there is no mass interaction. Okay. And the open system is a system where both energy and mass interaction take place. Example of open system is a boiler, turbine, compressor, nozzle, diffuser, heat exchanger. Most of the engineering devices are based on open system. Okay. And if we apply the first law of thermodynamics for open system, then it is called steady flow energy equation. Steady flow energy equation. Okay. This is also called as first law of thermodynamics for an open system. Okay. So before understanding what is first law of thermodynamics for open system, let us firstly understand what is first law of thermodynamics for a closed system. For a closed system undergoing a process, first law of thermodynamics is given by del Q is equal to del W plus du. This is first law of thermodynamics for a closed system. Okay, for closed system, where del Q is the heat which is transferred to the system, heat supplied to the system. Del W is the heat work done by the system, and du is the change in internal energy of the system. Okay. And the assumptions which are used to write this equation of first law of thermodynamics is that the system should be a closed system. Okay? If the process is quasi-static, also, then the work done can be written as del Q is equal to P dV plus du. So, you all must have studied the first law of thermodynamics for closed system. Okay? And for the closed system, this work is also called as boundary work or non-flow work. Okay? And the work which is used for open system is called flow work. Okay? Now today this is about first law of thermodynamics for closed system. Okay? Now I am going to tell you about first law of thermodynamics for open system, which is also very important, as seen from the previous year papers of GATE exam. Almost every year or every alternate year, one question definitely comes from first law of thermodynamics for open system or steady flow energy equation. Okay, either the question is from nozzle or turbine or compressor, one question definitely comes. Okay, so this topic is very important for GATE point of view. Okay, now what is steady flow energy equation? To understand steady flow energy equation, firstly we should understand what is steady. Steady means when the properties of the system do not changes with respect to time, then it is called steady. Okay, when properties do not changes with respect to time, then it is steady system. Okay. So time independent properties is actually called steady system. Okay, it is related to steady. Now let me tell you with the help of an example. Well, suppose that you visit a power plant. Okay, you go to a power plant, or if you want to take the reading of any system which is based on open system. Okay, for example, you want to take the reading of temperature of turbine at the inlet of turbine. Okay, so the reading that you take in the power plant for turbine, those readings are actually steady state readings. When the conditions become steady or almost constant with respect to time, then we used to take the reading. Okay, so most of the applications are open system, and those open system are actually running at steady state condition. Okay, we need to study the parameters for open system based on steady system. Okay, and what is flow energy? Flow energy means the energy which is required for maintaining the continuous flow of mass for the control system in case of open system is called flow energy. It is also called as flow work. Okay. Now firstly we will discuss what is flow energy or flow work. See, what is flow energy or flow work? Flow energy or flow work. As we have discussed about non-flow work is the work which is used for, also called boundary work, used for open closed system. Similarly, for the open system, for a given control volume, the work which is required to maintain continuous flow from inlet to outlet, the energy which is required to maintain a continuous flow from the inlet to outlet of a given control volume. Suppose this is a control volume where our study is focused. Okay, this is your control volume. Okay, I hope you all know that the system, in case of open system, it is also called as control volume. All right. Now, Deep is asking about is there any plan for other subjects live stream. Well, there will be plan for all the subjects for GATE exam, okay, but it will be launched very soon. As we can see that most of the students are busy in other exams, like either you are busy in your MTech counseling, or some of the students are busy in RRB CBT 1 exams, okay, or preparing for other exams, okay. So we will be delaying we will make a reschedule of the complete GATE 2020 course on the YouTube channel, okay, so that your participation in number can be increased, okay. If you are busy in some exam preparation, you can do that, and then you can later join the session, okay. So because it's not important if you are not coming the live class, then it's not important to take the live class, okay. And to get the complete knowledge of the subject Surya Vishnu, you can refer to 2 books. They are good books, P.K. Nag and Sengels and Bose. These are good books for thermodynamics. You can refer to that book, okay. So the energy which is required for maintaining a continuous flow across a controlled volume is called flow energy, also sometimes called as flow work, okay. And this flow work is equal to P into V, that is product of pressure into volume. Flow work is the product of pressure into volume, okay, and this flow work is used for open system for maintaining continuous flow across a control volume, okay. Now to write the steady flow energy equation, let us take a control volume. Let us take a control volume. Okay, suppose this is inlet and this is outlet. Okay, this is your control volume. Suppose the mass entering in the inlet is m dot I and at the outlet is m dot E. Okay, this is the mass inlet, mass outlet. Okay, and also the internal energy is UI, enthalpy, specific enthalpy is HI, pressure is PI, volume is VI, small vi. Okay, and potential energy head is ZI and velocity capital VI. Okay, these are the properties at the inlet, where Mi is the mass at the inlet, Ui is the specific internal energy at the inlet, Hi is the specific enthalpy, Pi is the pressure at the inlet, and small vi is the specific volume or volume at the inlet, Zi is the potential energy head at the inlet, and Vi is the velocity at the inlet. Okay, same parameters will be at the outlet, that is Me, Ue, He, Pe, Ve, Ze and capital V. Okay, so these are the properties at the inlet and outlet. Okay, and this is our control volume. Now what is our purpose? Our purpose is to write a steady flow energy equation for this control volume. Okay, now to derive the steady flow energy equation for this control volume, we will be using 2 equations. First equation is conservation of mass. First equation is conservation of mass. Okay, what is conservation of mass? Conservation of mass is that the mass flow across this control volume is conserved. Okay, that means mass at the inlet is equal to mass at the outlet. Okay, this is conservation of mass which will be used. Second is conservation of energy, that is total energy is conserved. Conservation of energy, as we all know that as we all know that first law of thermodynamics is also called as law of conservation of energy. Okay. So, for deriving the steady flow energy equation, the second conservation equation which will be used is conservation of energy. That means total energy from the inlet and outlet will be conserved. Okay. Now, apart from all these energies, one more energy will be there which will be flow energy. As we have discussed, for the open system, one more energy will be there, that is flow energy. This flow energy is equal to m times of flow work, which is P into V. This is called as flow energy. Okay. Now, this flow energy at the inlet will be equal to Mi dot Pi into Vi, and at the outlet this will be at inlet, and at outlet it will be Me into Pe into V. So, these are the flow energy at the inlet and outlet. Okay. Now, to write the steady flow energy equation, I will be clear the board first. Okay. So, what is first law of thermodynamics for a closed system? It is del Q is equal to del W plus du. That means, or we can say that difference of this heat and work is equal to change in internal energy. Okay. Now, same equation will be used. Naresh Kumar, flow energy means the energy which is required to maintain a continuous flow across a control volume. This flow energy is also called as flow work. Okay. Flow work, if you multiply the flow work with mass, it becomes energy. Okay. Very similar to that, if you multiply work with mass, it becomes power. Okay. So, the flow energy is equal to product of mass into flow work. Okay. And this flow energy is required for open system to maintain a continuous flow across the control volume. All right. Now, in this open system analysis, this PV is called as flow work. PV is known as flow work. Okay. So, if we multiply this flow work with mass, it becomes flow energy. Okay. Like power is equal to m into W. If W is in kilojoule per kg and this mass is in kg per second, it becomes power. Okay. Similar to that, this flow energy or flow work is equal to Mi into Pi into Vi. Okay. Now, this to write the first law of thermodynamics for open system, we will be using this equation as a reference for closed system. This heat and work, the heat and work in case of open system will be written as del Q dot and del W dot. What is the meaning of this dot? This dot means del Q over dt or del W over dt. Because in the open system analysis, yes, Naresh Kumar, you are absolutely right. For the closed system, work done is equal to P dV. For open system, it is equal to P into V. Okay. So, in case of open system, the work and heat changes are seen with respect to time. Okay. So, they are actually with respect to time. This is time, not temperature. This is actually with respect to time, because it is a steady flow energy equation. Okay. So, we will be using a dot here. All right. Now, the steady flow energy equation will be Mi into Ui Ui is the internal energy at the inlet, okay, plus Pi into Vi. Pi into Vi is the flow work at the inlet, okay, plus Vi square by 2. Vi square by 2 is actually the kinetic energy at the inlet, okay, plus G into Z. G into Zi is the potential energy at the inlet, okay. I hope this is clear to you. This is actually total energy at the inlet. Total energy at the inlet, which is sum of internal energy plus flow work plus kinetic energy and plus potential energy, okay. And also there will be heat at the inlet, okay. Some heat is supplied at the inlet, okay. Now at the outlet it will be equal to ME UE plus PEVE plus VE square by 2 plus G into ZE plus W, okay. So at the outlet, this is the equation at the outlet, okay. So this is the energy equation, this is the equation at the inlet, outlet, this is the equation at the outlet. So when we equate these two equations, it will become steady flow energy equation, okay. So if we equate it, it will become ME into UE plus PEVE plus VE square by 2 plus GZE plus W, okay. I hope it is clear to you. This is steady flow energy equation. Now the sum of this value, we know that sum of internal energy plus P into V is equal to enthalpy. We know this thing. I have told you H is equal to U plus PV. H is equal to U plus PV. Enthalpy is the sum of specific internal energy plus flow work, okay, or flow energy. So we can write it as HI. So this will become MI into HI plus VI square by 2 plus G into ZI plus del Q dot is equal to ME HE plus V square by 2 plus G into ZE plus work done, okay. Now this equation, my dear students, is called as steady flow energy equation for a open system. This complete equation is called as steady flow energy equation, which is used for open system. Now you have to use this equation in your exams to solve questions, okay. Now when this equation is used for different devices like boiler, turbine, compressor, nozzle, diffuser, throttling devices, then that becomes steady flow energy equation for different devices, okay. So now I am going to tell you what will be the steady flow energy equation for different devices, okay. So I hope this equation is clear to you. All the properties have their usual meanings, okay. So this is mass at the inlet, specific enthalpy, this is kinetic energy, this is potential energy at the inlet, heat, and same at the outlet. So Surendra Yadav, right now the classes will be on the YouTube channel, which will be free first. After that we will come with a paid course, okay. So firstly the classes will be free, okay. Now I am going to tell you the steady flow energy equation for different devices. What are the steady flow energy equation? Steady flow equation for different devices. Okay, so first device is turbine. First is turbine. Okay. Now turbine, as you all know, that it is used in Naresh Kumar. Steady flow energy equation comes in the GATE exam in 2 marks. Okay. It comes in 2 marks. This is a topic which often comes in the GATE exam. Okay. And it is always asked in 2 marks or sometimes in 1 mark, but most of the time it is asked in 2 marks. Okay. Because it is a numerical topic, so most of the time it is asked in 2 marks. Alright. Now, as you all know that turbine is used in the power plant. It is used for steam power plant, gas turbine power plant and hydroelectric power plant. And the main purpose of the turbine is to produce power. Okay. As we all know that the steam from the boiler goes into the turbine and it rotates the shaft of the turbine. That shaft of the turbine is connected to the shaft of the generator. Okay. So basically the steam from the boiler goes to the turbine and inlet. Okay, it goes to the turbine inlet, and from here the shaft, it is connected with the shaft of the generator. This is connected to the generator shaft. Okay, so the power which is produced from the turbine is the steam energy, or the steam from the boiler is used to supply the power to the turbine, and this finally turns the shaft of the generator, and this is how electricity is produced in the power plant. Okay. So this is used for every power plant, either it is steam power plant or gas turbine power plant or hydroelectric power plant. Okay. Now in this turbine, suppose the enthalpy at the turbine is H1 and at the outlet this is H2 or HE or HI. Okay. So the assumptions that which will be used here, first assumption is that changes in kinetic energy and changes in potential energy will be 0, and the turbine is adiabatic. Adiabatic means there is no heat transfer. That means this turbine is insulated. It is insulated. Okay. So there will be no heat transfer also. So these are the assumptions, and after applying the assumption, we will get work done by the turbine which will be equal to M into HI minus HE. Work done by the turbine which will be equal to M times of HI minus HE, where HI is the enthalpy at the inlet and HE is the enthalpy at the outlet. Okay. So the unit of enthalpy is in kilojoule per kg. Alright. So from here you will get the work output from the turbine which will be equal to M into HI minus HE. The opposite of turbine is called as compressor. The opposite of turbine is compressor. In the compressor, what happens? Yes, in the compressor, the air at the compressor is used to compress the air. It increases the pressure and temperature. Okay. So work is actually supplied to the compressor to compress the air. Okay. So the work done by the compressor will be a negative work, because work is done on the compressor. and since work is done by turbine, turbine work is always a positive work. Okay, turbine work is always a positive work because work is extracted from the turbine, work is produced by the turbine. Okay. Now the opposite of turbine is compressor. What does compressor does? Compressor actually increases the temperature and pressure of the air. Okay, and for that we require work which is done on the compressor. Okay, so the same assumption will be used for compressor, but the diagram will be opposite. This is the diagram of compressor. Okay, so enthalpy at the inlet and enthalpy at the outlet. All right. So the work which is done by the compressor is equal to m into h e minus hi. It is just opposite of turbine. We just use a minus sign here. Okay. So when we use minus sign here, it will become a work done by the compressor. Okay, because compressor work is equal to minus times of turbine work. This is not actually minus sign of turbine work, but in the formula, to remember the formula, the compressor work is a negative work and turbine work is a positive work. Okay, because work is done by the turbine and work is done on the compressor. Okay. HK Technology is asking a question. I don't understand what is XE stream. Can you tell me the full form of XE stream? Are you talking about double E stream or electrical stream? Okay. So work done by the compressor will be He minus Hi into m. This is compressor. All right. Now next. Next device is nozzle. Next device is nozzle. What is the purpose of nozzle? As we all know that nozzle is used for jet engine, spacecraft. Also you can see the use of nozzle in your garden also. In the garden, when you used to water the flowers, you make use of this nozzle in the form of jet, okay, to water your flowers. Okay. So there are different applications of nozzle. Okay. Now in the case of steady flow energy equation, when we apply the steady flow energy equation for nozzle, the assumptions which are used are changes in potential energy are 0. Also there is no work done by the nozzle. Work done by the nozzle is 0, and also it is insulated. So these are the assumptions which will be used for deriving steady flow energy equation for nozzle. Okay. And the equation that we get for the nozzle is that only energy that we extract from the nozzle is kinetic energy. Okay. So the only energy that is used for flow in the nozzle is called kinetic energy. Okay. So if we apply steady flow energy equation for nozzle, it will be m times of Hi plus Vi square by 2 is equal to Me plus He plus Ve square by 2. Now in your exam, nozzle, most of the time nozzle question from nozzle comes in your exam. Okay. And what mistake you do in your gate exam is that the mistakes comes in the unit. First of all, First of all, in the nozzle, the velocity at the inlet, is almost very small as compared to outlet velocity. So this velocity, it's taken as almost 0 in case of nozzle. Okay. So the steady flow energy equation for nozzle reduces to since mi is equal to me, it gets cancelled out. So this becomes hi is equal to he plus ve square by 2. Now what is the catch here? The catch here is that this hi and he have the unit of kilojoule per kg, and kinetic energy, this is the kinetic energy having the unit of meter square per second square, which is equivalent to joule per kg. Okay. To solve the question, you have to convert this joule per kg in kilojoule per kg. So you have to divide this kinetic energy by 1000. You have to divide it by 1000 so that it becomes equivalent to the unit of specific enthalpy, which is kilojoule per kg. Okay. So this will become velocity at the outlet will become square root of 2 times of 2 into 1000 hi minus he. This will become the exit velocity at the nozzle. Okay. So you have to be very much attentive about the unit in the exam. If the unit of enthalpy is in always it is in kilojoule per kg, it will be given in your exam also. So you have to multiply by 1000, then only you will get the exit velocity. Okay. So this is the formula for velocity at the outlet of the nozzle. Okay. Well, Mohan, Dinesh, these classes which are going on our YouTube channel, these are completely free. Okay. And there is no price for these classes. Okay. So when you will come with the paid classes, then there will be a price for that. But on the YouTube channel, the classes are absolutely free. Now same if you want to apply it for diffuser, the opposite of nozzle is called diffuser. Opposite of nozzle is called as diffuser. Okay. So in the diffuser, what happens? Diffuser is somewhat like this. So velocity at the outlet is almost very less than velocity at the inlet in case of diffuser. Okay. So this equation in case of diffuser becomes hi plus vi square by 2000 is equal to he. Okay. So this will be the equation for diffuser, and this will be the equation for nozzle. Okay. So I hope it is clear to you what is nozzle, diffuser, and what is the steady flow energy equation for nozzle and diffuser. Okay. The last device that we are going to discuss is throttling device. Well, throttling devices are used in basically used for refrigeration purpose in the refrigeration industry. Okay. You can see the example of throttling device in the form of capillary tube or flow through porous plug. That means if the flow is through a porous plug. Okay. Flow through capillary tube. Capillary tube is a tube which is having a decreasing cross section. Okay. So you must have seen this capillary tube in your refrigeration industries. If you visit a refrigeration lab, okay, so there you will find the capillary tube, okay, and it is also flow through orifice, or flow through partially opened valve. So these are the application where throttling is used, okay, and main thing in the throttling, what happens, the pressure is reduced so much such that the temperature also reduces, okay. So that's why throttling devices are basically used in refrigeration and air conditioning application, okay. And this throttling devices, in the throttling devices, heat transfer is 0, work is also 0, also there are no kinetic energy changes and potential energy changes. So for the throttling devices, if you apply steady flow energy equation, it will become H1 Hi is equal to He. That means for throttling device, the enthalpy at the inlet will become equal to enthalpy at the outlet, okay. So this throttling process is also called as isenthalpic process. Throttling process is also called as isenthalpic process because enthalpy at the inlet is equal to enthalpy at the outlet, okay. So these are this was another application of steady flow energy equation for throttling devices, okay. So these were some application part of steady flow energy equation. Now what you can do is, some of you is asking about practicing question on nozzle. Well, on the nozzle you can practice the question by yourself, okay. You have to just use this equation, Hi is equal to He plus V square by 2000. You just have to use this equation, okay, Ashish Mishra. And there are some question in GATE 2018, in GATE 17. Also there was a question in GATE 16 and 15. Okay, so you can solve the questions for previous 3 to 4 year question on steady flow energy equation today, and I am telling you whatever concept I have told you in the class, if you are going to apply those concepts, you will definitely solve the questions, okay. So you can solve the previous year questions of GATE. In this year, there was a question every year in 2018, 17, 16 and 15. There was question of steady flow energy equation, okay. So you can solve the question of steady flow energy equation from previous years, okay, and there you can use this concept to solve the question, okay. You just have to remember one thing, okay. Whenever a question comes from steady flow energy equation, if you directly know the equations for turbine, compressor, nozzle, diffuser, throttling, then it's okay. If you don't remember in the exam, you just have to remember one equation, which is Mi Hi plus Vi square by 2000 plus G into Zi plus Q is equal to Me into He plus V square by 2000 plus G into Zi plus W. So in the exam, you have to remember this equation. Now, if the question is from nozzle, you have to apply the assumptions of nozzle and then you can solve the question. Okay, because sometimes in the exam, in the GATE exam, what does they do? In the assumption of nozzle, we say that nozzle is insulated, there is no heat transfer. But sometime in the GATE exam, there is a question in which heat transfer will be given to you. They will say that there is some heat loss which is taking place. Okay. Also, they can say that there is some work done also. So, in that case, you have to remember this equation. Okay. So, sometimes in the previous year also you can see, sometimes they give this, that there is also a heat transfer which is taking place. I think there was a question in 2017 only. There was a question in 2017 also, that there is a heat transfer and there is also some work done, and enthalpy at the inlet and outlet is given to you in the nozzle, for the nozzle. Okay, so in that case you have to apply this steady flow energy equation to solve the question. Okay, so I am not just saying that you just directly go and use the equation for nozzle, diffuser or turbine compressor. If in the exam there are some given values, you have to use this equation and then you have to put the values and solve the question. Okay. Now, Ashish Mishra is asking about relationship between pressure and efficiency of nozzle. Yes, as we know that in the nozzle what happens, velocity at the exit of the nozzle is very, very high as compared to at the inlet. Okay. So, as you know that this velocity is dependent on pressure. Okay. So, when velocity is high, their pressure will be quite low. Okay. So, there is definitely a relationship between pressure and velocity and also the efficiency of nozzle. Okay. So, efficiency of the nozzle is directly related to the kinetic energy. Okay. So, I think efficiency of the nozzle is related to the kinetic energy at the outlet over difference of kinetic energy at the inlet and outlet. Okay. So, basically efficiency I think depends more on the velocity rather than we can say the pressure. But yes, pressure plays a very important role in case of nozzle. Okay. So, yes, Ashish, if you are asking that if we double the pressure, we know that if we are saying that nozzle is adiabatic, so for the adiabatic we will use this equation. Okay. Now, you can find it from here. If you double the pressure, there will be a change in velocity also. Okay. So, we can say that velocity is also related to pressure. So, how they are related? This will be related as P1 by P2 over 1 by gamma into V1. So, you can see from here if the pressure is increased, the velocity will reduce. Okay. And I have also told you that there is a relation of efficiency and velocity. Okay. So, you can calculate from here that what will be the relationship between efficiency of the nozzle and the pressure. Okay. All right. Sorry, this will be P1 over P2. This will be P1 over P2. Okay, so you can see from here what will be the relationship between pressure and velocity. Okay, because we assume that nozzle is adiabatic, it is insulated. So, for adiabatic process, this will be the equation. Okay, so this will be the equation for nozzle, and from here you can see, Ashish, if you double the pressure, there will be a change in the velocity also. Okay, there will be a change in volume and there will be a change in velocity also. All right. So, pressure is related to volume. All right. Now, this was a demo class. No, this is not a demo class. Well, this is a class for our GATE 2020 mechanical engineering course. Now, you can see from the number itself that we have actually launched a YouTube course for which is a free course for mechanical. But I think you guys are preparing for some other exams like RRB or SSC, and that's really good also. You all should prepare for other exams if you are if you have applied for some other exams like BHEL or RRB, SSC or any other public sectors. Okay. So, GATE exam, we have started this course on the YouTube channel, which is completely free. Okay. And in the previous class, I have done an orientation for GATE mechanical engineering course. Okay. You can find that video on this YouTube channel only. All right. Now, we have thought that we should reschedule the course so that according to your availability, we can plan the classes. Okay. So that you will be available online, so that you can study, because these classes are for you. If you are not there in the class, then what's the point of giving the classes, that too live? Okay. So, we will be conducting the classes on the YouTube channel, which will be free, but we will reschedule the classes so that we can see that if you are busy right now in some other courses like RRB, SSC, then accordingly after your exam we can plan the classes. Okay. So, very soon we will come with another schedule of the GATE 2020 classes for mechanical. Okay. So, till then, thank you and have a good day. And those who are preparing for RRB exam, there are rapid revision classes for CBT 1, which we are conducting on the YouTube channel only. Okay. So, you can study for that. And Study for Success is having a comment that he is preparing for the GATE exam from the last 3 years. Well, you need to analyze your weaknesses. What are the mistakes that you are doing from the last years? Okay. Maybe you are not able to revise the concept in the end, and you are forgetting the concept in the exam. Okay. So, because GATE exam is totally unpredictable. Okay. Maybe if you are having a good knowledge of the concept, there are some calculation mistake also. Okay. You can do some calculation mistake in the exam. Okay. So, you need to be accurate. You need to be very much good in memory. You should memorize your concept. You should solve the numerical very well. Okay. Then only you will get a good rank. Okay. It's 90% your hard work and 10% your luck in the exam. Okay. So, you need to dedicate your time. You need to practice the question. You need to increase your accuracy. You have to attend the test series. So, this is how you will get a good rank in the GATE exam. Okay, study. This is all for the class, and this is the Thermodynamics and Application Part 1 class. The next class will be rescheduled. Okay, and you will get the schedule of our GATE 2020 course, new schedule very soon. So, till then, you can follow our YouTube channel. You can subscribe to it. You can so that you can get latest videos regarding GATE exam or other competitive exams. Okay. So, thank you so much for giving your time, and thank you and have a good day. Thank you.